Hello, pre-calculus, and welcome to our third video in this online series with me, your host, Mrs. Martin. I'm glad you all could make it to another video with me. And if you missed the last video, please stop this one now and go back to that video. That video from yesterday, Tuesday, March 24th, was the introduction to exponential functions, and it's important that you you watch and understand that one before watching this one, which is just an extension to yesterday's notes. Okay, so we're using these videos as sort of lecture, and to those of you who were asking about the videos yesterday, I apologize. I ran into some technical difficulties and it was taking very, very long for these videos to render yesterday for whatever reason. So again, I apologize if you were waiting for those. A lot of you were sending me messages asking me where they were, and I was half stressed out, and then the other half I was really happy because I had students asking me for lecture videos, so that made me feel kind of good. So thank you for doing that and making sure that I'm staying on top of my material so that you guys can stay on top of your material. I'm happy that so many of you are taking your learning so seriously. So today's video should be pretty short. I just want to make an extension on the lecture notes that we did yesterday. Again, it was an introduction to exponential functions. So today, we're going to call this one, our notes will be an extension. Okay, so just a few things for us to know. An extension of exponential functions. Okay, so here's a few more things you should know as we continue on with our work on exponential functions. First of all, you know it's my favorite thing to talk about domain and range. I'm not even with you guys, and I could almost hear the distress, hear the groans of pain with me saying the words domain and range. But think about how you started out, and I really want you to remember that you've done much better with domain and range, and we've gotten really good at it, and we're going to go ahead and extend that into our knowledge of exponential functions. Some of you may have already seen this domain and range of exponential functions. Actually, you might have already been exposed to it in Khan Academy from class, but let's go ahead and continue on so we can make sure that everybody's on the same page. So I'm going to go ahead and start here with domain. So I'll do this in black. So here's domain. And then I'll continue on with range. So the function that I have here, let me start with that. The function that I have here is y equals 2x. And you guys can see it over here on the left side. Okay, I graphed it in Desmos just for the sake of us learning about these things. And I'm going to go ahead and start by writing my domain and range. So my domain here, okay, think about the values of x that are possible, right? Like what things can I actually plug in to this function 2 to the x power? And if I think about it, can I plug in negative numbers? Sure I can. I can plug them in all the way to negative infinity, right? I can go all the way into the negative side, keep going, keep going. There's no limit to what negative numbers I'm allowed to plug in. So right away, my domain is negative infinity. Okay, that's where I'm going to start out. All the way, all those negative values are possible. So I continue to think about things. Can I plug in, for example, a 0? And yes, the answer is sure. Yes, I can. If I come over here and I actually tap on my function, 0 as a value of x is available on the graph. So 0 is possible, so I can continue on through there. And then I can go ahead and think about all the positive values that this exponential function can take in for its x component. It doesn't look like it goes very far, right? Just in this little snapshot of the graph, it looks like it doesn't go further past 5. But if I think about things that I'm allowed to plug in, I'm allowed to plug in way past 5 as well. I can zoom out to prove this, but last time I tried this, my Desmos crashed. Again, it starts to get very steep, but is it possible? Yes, it is. I can plug in any positive real number that I can think of. So my domain actually ends up being negative infinity to positive infinity. Okay, now is that going to be the case for other graphs? We'll see that a little bit later. Let's go ahead and talk about range, because range might give us some trouble. So thinking about range, again, let's start with the negative values, because we're always writing domain and range from least to greatest. So thinking about our negative values, could I ever yield negative values when plugging in things for x? Now, if you remember from the last video, our answer to that was an easy no, right? Anything that I plugged into x made this function stay positive. 2 to the negative 2x is equal, I'm sorry, 2 to the negative 2 is equal to 1/4. 2 to the 4 is equal to 16. 2 to the 0 is equal to 1. So in the last video, we worked through a bunch of other examples, but we noticed that we couldn't ever be negative. We couldn't ever have an output of 0, because remember, ranges are outputs, right? So no negative outputs, no output of 0, only positive outputs. So I can write that like this, okay? The positives are infinite possibilities for positive numbers, but we just can't be 0. So notice that I did not use a bracket, because that would imply that I'm allowed to have an output of 0, and we just discussed that we don't have an output of 0. So I'm going to go ahead and erase this stuff because we don't need it. But that's our range. For those of you who like interval notation, inequality notation, you could also write that all my y values are greater than 0. And for my domain, I could say all real numbers. Okay, let's try a different function, a different exponential function. I'm going to go ahead and let's multiply this function by an initial value of -3. Okay, so here's my initial value of -3. It's doing a few different things now, so I'm going to make another one here. Y equals -3 times 2 to the x. Okay, my domain for this one, it's going to end up being the same. Okay, our exponential functions can take all input values that are negative, input value that is 0, input values that are positive. So again, negative infinity to infinity. That didn't seem to change. All real numbers. Okay, now the range is where we see some things changing. Our y values is where we've got some change happening. Okay, so again, we got to think about these things. Remember that 2 to the x was always positive numbers? Well, now this 2 to the x just got multiplied by a negative number, specifically a -3. And we all know what happens when we multiply a positive number by a negative number. That becomes a negative number. So in this situation, again, I'm never going to have any zeros, but I'm also never going to have any positives anymore, because this is always a negative number times a positive number, which gives us a negative. So with that in mind, I now have negative infinity to 0. Okay, those are all the possible output values for this function. Again, notice that I didn't put 0 to negative infinity because our interval notation makes us write things from least to greatest. Okay, and I can also write that y is less than 0 in this case. Now, in our homework, we had the situation where we moved, we moved our asymptote up and down. Let's go ahead and move this one. We'll move it up 2. Okay? Which means the asymptote here is no longer 0. The asymptote is now y equals 2, just to kind of give us a visual. So when I look at this function, -3 times 2 to the x plus 2. Again, we have a few different things happening. Domain doesn't change. This is pretty standard for exponential functions. Let me give us some lines here. Okay, that's pretty standard. The range is where we've got things going on. So our function just moved up 2. And so looking at that now, instead of stopping at 0, we're stopping at 2. So again, it's still a bunch of negative y values available, right? This whole function goes all the way down, keeps getting negative. But it can get all the way up to its highest value, which is going to get infinitely close to 2. So there's our range. Y is less than 2. So just a few things about domain and range to be aware of. And hopefully this supports you in answering questions for your homework 8, which is being assigned today.